Recording. We are now moving on to 5.4, solving equations. Please note, this is no longer left side equals right side. You can start rearranging things because we're not trying to prove anything. You can do algebra, you can do cross multiplication, you can do anything you want. Okay? As long as it's mathematically sound. You can't add one side and then multiply another. That's not true. That's not true algebra. But this is what I mean. There is no invisible wall, so I am going to go ahead and solve all answers for x, all angles of x, that make this true in this interval. You might be asking, oh, that's new. This part you've never seen before. Let me tell you why. Judging from the curves that we have drawn up until now, what is so special about sinusoidal curves compared to other curves, other graphs? The one thing, Ian? They repeat. In other words, if there's an answer, if I'm saying, when is this curve equal to a y value of 1? You'd be like, oh, hey, y equals 1 when x equals 3 pi over 8. Well, y also equals 1 here. It also equals 1 here. It also equals 1 here. In other words, there's an infinite number of answers. And so every single one of these questions is going to have an interval, a domain that I want you to focus on. And you have to give me every single answer that fits in that domain. In other words, there's an extra layer of something you have to think about after you answer. So I'm going to answer this question for just 0 to 2 pi, because that's one circle. And then I'm going to consider if there are any answers that also fit into that interval. Why does that make sense? Well, graphically speaking, think about it like this. Zero to 2 pi is this. 0 to negative pi, or negative pi to 0, will be that. So I want to see how many answers there are in quadrant 1, 2, 3, 4. But if there are answers in quadrant 3 and 4, these two angles end up being coterminal with those two. These two will give rise to another two answers. Here's another way I can describe it. You know that the sine curve continues on forever. In the same way, you can say that it continues on forever this way. The question is asking, let's use red here, find all the answers within this portion of the curve, within this portion of the curve, and this portion of the curve. Because this is negative pi to 0, and then 0 all the way to 2 pi. So keep this in mind. I'm going to come back to this in just a second. I'm going to take this equation, I'm going to rearrange it, and apply it to this picture so I have an idea of how many answers I should be getting from this question. Alright, here we go. 2 sine x plus 1 equals a 0. I am trying to solve for x, so I am going to rearrange everything to get x as alone as possible. Cast rule. Which quadrant am I dealing with? 3 and 4, correct. So I am dealing with there, so I should get one answer there. I should get another answer there. But I also have to include the negative angles when I go backwards, so it's going to be one answer there and one answer there. So I'm going to get 4 answers for just this question alone. Another way I could think about it is, remember, the sign has a minimum of -1. So how many points cross this dotted line where y equals -½ 1, 2, 3, 4. I'm going to get 4 answers. Let's try it. So 2 things I recommend you try and calculate when solving this. Number 1, what quadrant are we in? And then using cast rule, you should probably figure out what is my acute related angle. That will help you a lot. So using this, okay, therefore x is in quadrant 3 or 4. Also, let's figure out our related angle. Also, if we're dealing with our acute related angle, and it gave me a positive answer, what is the acute related angle? What angle gives you a positive 1/2 in quadrant 1? Special triangles, special triangles. 30, yes, pi/6. Good. This is my acute related angle. I am going to apply this angle into quadrant 3 and quadrant 4. That will be theta is equal to pi plus the acute related. So it's pi plus pi/6. This becomes 7 pi/6. If it was quadrant 4, the angle is 2 pi minus the related, which means my answer would be 2 pi minus pi/6, 11 pi/6. All right, I'm going to stop right there just to do a bit of a checkpoint. Up to here, I think, this is a harder grade 11 question because you have to use cast rule and you have to think carefully. Any questions so far? I'm not saying it's grade 11 material to demoralize you or make you belittle you. I'm asking this to make sure that you're not missing anything or nothing is particularly confusing just before I move on to that final step. Because we finished for 0 to 2 pi, and I said we're going to do for both. Pi/6? Sure. So this theta, assuming if we were in quadrant 1, it would be like that, where because it's a sine, it is opposite over hypotenuse. So the only special triangle that can give you 1, 2, and therefore √3 as the x value will be pi/6, 30 degrees. So I knew it was going to be pi/6. Okay. Any other questions? Going once. Yep. Say that one more time.
Since you know like the points and each like different interval that you gave, so
Uh-huh.
2 pi and negative pi to 0, they're both gonna be in like when you give like a little like graph both of them, you highlight like quadrant 3 and
Yes.
4, like why aren't they just like the same point then?
They are the same point. They are coterminal. Right? Being in the same quadrants, a certain angle will get me to quadrant 3. A certain angle will get me to quadrant 4. But a certain negative angle will also get me to quadrant 3, and a certain negative angle gets me to quadrant 4. So the angles will be a negative, and you will see how. So I'm going to use Sam's idea, saying if we know they're in quadrant 3 and quadrant 4, aren't they going to be the same value? In a sense, it is, but the key word is that they're going to be coterminal. They're going to be different by a full wavelength. Or, sorry, I'm getting to physics here. A full period. They will be coterminal by a full period. So what's a full period for my untransformed, I guess, sine curve? It's pi over 2. Sorry, 2 pi. So I could say then, so for negative pi to 0, which is in quadrant 3 and quadrant 4, the theta is going to be coterminal with 7 pi over 6. But on the left side of the axes. So you can say it's going to be 7 pi over 6. I'm going to subtract by 2 pi, which will get me 5 negative 5 pi over 6. And in quadrant 4, you're going to get me 11 pi over 6 minus 2 pi, again coterminal, and I get negative pi over 6. So those are my 4 answers. All 4 of those angles will give me this statement. Yes? Pardon me? Not a circle is a little I mean, I could. So this would be that. Can you see that? This would be there. Okay? Are you sure? Okay. This would be the same line, but negative 5 pi over 6. Coterminal. Remember, if I have like 315 degrees and I have negative 45 degrees, are they coterminal? What did you do? You added or subtracted a 360, right? Negative 45 degrees plus 360 gives me positive 315. So they both both have the same terminal arm. This is 315. This is negative 45. Coterminal. Same arm. Just take a look at that. Hi, yes, he is. Oh, okay, sure. Okay, but this one. Okay. Mason? Yeah. I'm gonna have to grab your stuff, and the VP's asking for you. Okay. Have your phone there. Have your phone with you as well. Yeah. I'm not sure why they're asking to pack up your stuff, but. Questions? Yes.
So I just wanted to clarify, like the reason why you made sine, like when you talk about sine theta r and you make it in quadrant 1, is that just to find theta? Like why did you make it in quadrant 1?
Oh, well, if I wanted to find all the angles.
No, I meant like in the step above.
I know. if I wanted to find all the angles in quadrant 2, 3, or 4, I need to know what that little piece is. And that is why I pretended, you know what, let's pretend this is in quadrant 1 with a positive. And if I find this little piece right here, then I know what that little piece is, I know what that little piece is, and I know what that little piece is. Yeah. Castro. Yes, Maggie.
I know that you did it by like subtracting the ones that you already found, like subtracting the like rotation from it, which is 2pi. But could you also just like pretend that you're starting going the other way and just like throw a negative in front of it? Does that make sense? Like
That makes absolute sense, and I was going to get to that.
Okay.
Yeah. Did you do your bangs too?
I've always.
Oh, really? Oh, my bad. That's nice. Okay. Getting distracted. Good point. Everyone, you may not have recognized what Maggie was trying to get to. She's like, I don't want to do the coterminal stuff. That's extra work. Can I just look at this and map it out manually? By that, what I mean is, you can actually calculate what this angle would be, not by doing coterminal, but literally just having an idea of what that triangle is. I'll ask you once again, Vishaka, just because you asked, what angle are we dealing with if we are in quadrant 3? What angle is that? Vishaka? Pi over 6. So you know this is also going to be pi over 6. We're talking about the same angles here, right? Same angles. But if I were to go backwards, how far did I move if I am doing half of a circle in a negative direction? What angle is that? Negative pi. Good. And if I rotate back in the positive direction, how much did I rotate back by? Pi over 6. So you can also calculate this by saying the angle I'm dealing with is I rotate backwards by pi over, negative pi, and then I rotate forwards by pi over 6. And what's my answer? Negative 5 pi over 6. Yes?
So are we saying that the pi over 6 is when it's equal to 0?
Yes. When the x value is pi over 6, I will get a positive 1 over 2. That is why I have to apply it to quadrant 3 and 4. If I plug in 7 pi over 6, I will get the negative 1 over 2. If I plug in negative 11 over 6, that's when I will get the negative 1 over 2.
Okay, so we're trying to find all the possible x's that would give us negative 1.
Well, the answer, yes, correct. That was the goal all along. It's good that...
And we can't use the 11 pi over 6 for the second one because...
Well, it wouldn't be correct. It will give you the same answer, but a positive 11 pi over 6 is going in this direction. Another angle that would work would be going in the reverse direction by just negative pi over 6.
And we're only doing this because we're trying to find in the negative direction.
The reason why they asked for it, they gave me a certain domain and I have to give all the answers for that domain. That's all. How's this? It's good that we spent so much time. It's basically time for our walk. Okay, for the sake of the video, I'm going to stop here, and then when we come back from our walk, we will do example 2 and example 4. Example 4 is better. Okay, we're going to save example 3 for a little later. Okay, we'll do example 2 and 4 when we come back.